Hello Amiga coders, this is Photon again. The conclusion from last tutorial was that we need to finish our demo with some nice touches to make it match the music, and maybe also, fade in some things and stuff like that. So what I did in the meantime was upgrade. What I did in between the tutorials was to release a new version, the final version, as far as I'm concerned, for the time being anyway, of the player play routine. So I showed you how to include P6109, and now I ask you to include instead P6110, which is the latest version, with especially a fix for modules that use pattern loops inside patterns. My module doesn't, but it's a good exercise, so I've prepared this tutorial and I replaced this include name with P6110, put the play routine in my working directory, in its own directory, and copied and pasted the options. That's what I did, so it's a good exercise, I guess. So if you want the latest version, then upgrade. So let's see where we are. What's wrong with this scene? Well, you're asking me. Well, I don't know. I'll have to just try things and see what looks good. First of all, I think the bounce is too fast. Also, it contains... we should replace the scroll text with something interesting instead of a test text. What else is wrong? Well, do you recognize the cyan copper bar that we started out with? Well, it's cyan, which is not a very pleasant color, so maybe we can do something about that. Also, it's a bit lame, moving like that, and I think it's a summer song, sort of, so I was thinking we could tweak the background color towards blue, and remove those lame top and bottom bars. They were just there for explaining where the screen starts and stops. And we need to do something about the sprite. And I think it should just be something else and bigger, and it should move in a more interesting fashion. Also, I hope to show, maybe not in this tutorial, but when we finish the demo, it should have some transparency things, and I think we could add another effect, because we're not using that much raster time. How do you check how much raster time your routines take? Well, you could set the background color when you call the routines and set it back to black or something when the routines end. So, did we have a main loop somewhere? Yeah. So basically just change the background color to white. Before running our stuff, and set it back to black. And we're done. So basically we have all the time in the world. You can see where it changes to white, and then there's some copper instructions that changes it back to gray or whatever. And then where the black ends, that's where our code stops executing for each frame. Excluding the music play routine, which is running on interrupts for this module. I can just remove this check because there's no way we're gonna get near the limit for what the Amiga can do here in these simple tutorials. Plus, I'm showing you a way to do these things that is, well, efficient anyway. So, and so what did we want to do? Well, boom, 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 boom. Let's change some background colors in the copper. Simple things to get started, to get a bit more pleasant design. So just look for, as you can tell, I'm into other things in between these tutorials. So these could be removed and just, well, I don't know, I want to use this logo palette color, red, green, blue, so up that a bit, and we could move that to this very start of the copper. Well, after the initialization commands. And that'll give us a blue background. Then somewhere down here we reset it to black or something. Here's where it goes back to the background color, so we made a change there. And we turn off the bit planes, which does not affect the background color. With 0 bit planes on, of course you only have one color to modify the background color, and no bit planes need to be on for the background color to work. Here's our font palette. So where's our black color coming from? Let's check. It's after these commands. What happens then? Oh yeah, maybe we're poking. Maybe we're poking this font palette. We probably are. Okay, font pal P. Yeah, that's obvious. So font E. So we just we should add 2 to this and add 8 to this. And set one less color. We should not set the background color. And that should fix it. As long as we go down here and tell it to please not set that color. Let's try that. Yep. But it gets a mismatch in the pointer there. Why is that? Okay. That's interesting. Oh, we can't remove a color and then add 4, can we? The whole point was, oh, that looks bad. And that's because the font was made for a dark background color, because the anti-aliasing colors were made for black. So we may need to change that. Instead, I'm gonna make the background color darker, I think. And then fix up the logo instead. Last minute choices makes for extra work, but we don't mind, because it's gonna be the best demo ever. So let's try some values. Didn't really help. So, and we need to reset it. So 6, we're gonna make a symbol for this. Where you want to put it. Before or after all these settings, I don't know. But we put the other stuff here, so. Better, I guess, but now the logo is borked. We're not gonna care about that right now. 2 to 4. I want to see how it looks. I want to put in a stop button here and to check how it looks because it's moving too fast. So basically what you can do is do this and only do that if we're gonna bit test the right mouse button instead of the left one, and if it is not pressed, there's business as usual, and otherwise you waste a frame by waiting for the next line and branching back to main loop. This is good. Well, you can see the s.s thing here that I typed by accident. Well, you can use .b. What happens is that if you know the branch is not far off, you can save 2 bytes by 2 bytes of code in the memory. Make your demo 2 bytes shorter by explicitly telling the assembler that the branch is a short one. You can use the AO command to assemble and optimize. And the assembler will automatically set all branches and branches to subroutines and so on to the correct distances. So there is just a habit for me to type .s. .s is not compatible with all assemblers, so by all means use .b. So now we have a freeze frame, and it doesn't stop the music because it's running on the interrupt. And I think that looks hunky-dory, actually. But somehow I would like the background to be brighter. But I don't want to re-anti-alias the entire font, right? So somehow get a shade in there or some sort of split thingy. Depends on whether we want the future effect to be full screen or not. I think it should be full screen. So let's think about that. The very first raster bar we made that goes up and down across the logo. That one is causing a bit of a problem because if we put in a copper shade manually in the copper, just wait every 10 scan lines or so and increase the blue color upwards, then the weights will have to take that, and we would have to weave sort of weave our weights into the weights for the moving copper bar there. So that's causing a bit of a problem. So we'd need a think on that. So what about something like this? That does not look good at all for the font, that is. 2 to 5. That looks okay, and it's probably the brightest we can go for the font. And that looks horrible. So 2 to 5 it is. And what say we put the fade at sort of the top half of the bouncing scroller area below the logo, and have the brighter color behind the logo. Or we could use another background, different color from the background color. Use a foreground color. The drawback being that we'd have to use overscan, because otherwise it would, like the scroller, I guess, here. If you check the left and right edges of the scroller, you can see they end before the left and right edge of this recording window anyway. And they will also, I'm coding this for a standard 320 by 256 display, sort of. So there's a choice to be made there. But, well, we'll try it. What the hell? So what we have here is 2 to 5. I'm gonna try 55A or something to just check what it looks like behind the logo there. And it actually looks pretty okay. 2 to A then. That's a bit too primary color for me. 44F should look about as primary color, but it's a cheerful bright color. And it's certainly a sky color, if ever I saw one. So, how about this? I'm just looking behind the logo now, and which will obviously need anti-aliasing, or who knows, maybe I'll completely replace it with something that looks better. What you can do is experiment in Deluxe Paint to get all these colors right, and then you'd know you wouldn't have to experiment with these things. So now we're gonna fade from 2 to 5 to 44F for now. So the way to do that is to, well, the simplest way is to just type it manually in the copper. I could show you some advanced, RGB fading routine, but Partly you wouldn't get perfect control over the fades, and secondly, well, it's way overkill for the stuff that we've done so far. So we know that this ends at 9.6, so we're gonna fade from here. I'm gonna set this to gonna make a symbol for that. I'm gonna set this back to the original value. We're gonna set logo BG color to 44F, was it? And we're gonna need, we can do this here just temporarily. Now we're gonna step this down some fashion. And 44D, C, 3, 3, 3, B, A, 9. Just counting down in hex here. 2, 2, 2, 2. 8, 7, 6. And that's our fade. So what we need in between is some weights, right? And we're going to use a trick to make. I can show you the unpleasant fade first, and then the pleasant one. And we need to. You can do this to just hide it from the eyes of the assembler. And we're gonna check the gap here between the logo and the top of the scroll bounds. Which is something like 64 pixels, I guess. So how many colors? 4, 8, 9. So that's about 8, let's say 7 scan lines per color change. So you use your hexadecimal skills. You can, well, if you have Windows or Mac or whatever, you can use your calculator, set it in programming mode, and test your hexadecimal skills. Calculate these values if you want. I bet there's some online hex test thingy that lets you get a score or something on your hex conversion skills. Anyway, it starts at this address, this position, I mean. Gonna put weights in between like that, and we're gonna add 7, so that's D, and that's, what's that then? 13, 16, A4, AB, plus that is 18 is B2, B9. That's a very benign position. I make a joke. First time in history. So anyway, that's our weights there, and we have a fade from one value to the next. I'm gonna paste that in between. I paste it after the last position of that moving copper bar, which is after the waitress thingy is there, and that's gonna be too late, so we're gonna have to do something. Perhaps we could move the font palette. I'm gonna put it here, and I'm gonna move this up to here, and make this weight earlier because the logo isn't full width, so we can move this in somewhat to make room for enough cycles for the copper to set the palette before before the end of the previous line. So well, that wasn't the expected result. So what did we do wrong? Oh, we didn't. We kept the red component at 4, which we shouldn't have. Oh, and we need to make one for the last one. BG call, right? And this top one should no longer be. This one should be. Yeah, that's correct. And we should set the first one to logo BG call. That's weird. Well, first of all, after the waitress stuff there, oops. After this, it should of course be set to the logo background color. Let's check that. Will probably not look very pleasant. And while it ends up at the correct color, we have some banding. And that means we have to check our bullshit. We're lowering the blue component. Why are we doing that? Well, we're fading the red and green components slowly and the blue component quickly, which is correct. But we might try some other things too. I'm gonna overlap it by 1. Check. Again. I should have used Deluxe Paint for this. Let's just do this and get it over with. Because that, according to me, should be quite correct. But as you could see, we had some banding, and partly that's because the Amiga palette is just 12-bit, as opposed to PC displays, which have, and AGA displays, which support 24-bit color, and that results in quite big steps in the color values. So to do that, a common technique is to put basically triple the size of this this mini copper list that changes the background colors. Let's see. We're introducing a new color here, so we copy that color twice, not thrice, and do it in a different way by adding 1 instead and reintroducing the previous color. That'll probably be easier to. Previous color. If you want, you can space them out so they're easier to see. For 4C, remember you have to copy this. You shouldn't just add 1 to this. And also we need to add to this. Keep on trucking. Was that 4-3C? Isn't that a break right there? Oh well, as I said, just keep on trucking. BAD. No, not that bad. 33B. 3, 1, 2, and Roger, copy that. Whoops. And soon we'll be done. Happy, happy. And we didn't fade out to our color, didn't we? Did we? So DC plus 7 is E. DC plus 7 is 12 plus 7 is 19 is 3. And that's our BG call. And that's our X226. And let's try that. Well, it's a bit smoother. And we've pretty much avoided the banding there, which came from the color becoming too gray. So I'm going to be happy with that for now, and let's move on. What else needs fixing? We said the bounce speed, didn't we? So already I forgot the name of the variable, so let's just go through and check. Scroll it to destination, bit offset. Well, we just changed the bit plane pointer in the main loop. So maybe just the weight. As you can tell, I've been away from the source a bit, so I don't remember how I did things. Well, let's check the carpal list, how it does it. Well, we set the screen bitplane pointer, right? So screen BPLP. When is that touched? Well, it's touched in bounce scroller. Very logical. So the obvious thing would be to lower the bounce Y-axle value. And that's already at its lowest value. You can't declare a word that is minus a half. So we need to work at a subpixel resolution there in the bounce scroller. Gonna set up bookmark. What we want to do is to keep this XL and speed and only make it affect the bounce Y less. And here we take the Y value as it is in pixels, multiply by a scan line and add it to the screen pointer, whereas we want to multiply it by less. We want to keep this y value as it is and shift it down. You can divide by 4, let's say. But a more efficient way to do that would be to shift it down by 2 instead. This needs to be done after you save the value to the y position, because otherwise it would be saved, shifted down, and that would result in the y position quickly settling on 0. It would be quartered every frame, so in 50 frames it would be 0 in, well, sooner than that, but anyway. So what's the initial value for bounce y? We need to multiply that by 4. As I said, the speed should be 0. It should start dropping from 0 with this acceleration, which is now a quarter pixel, whereas the bounce y should be multiplied by 4 for our calculations. So the calculations are from here to here, right? And the value is saved back with the current speeds and accelerations and whatnot. This would likely need to be multiplied by 4, where we reset the speed. But otherwise it should be okay. Let's try that. Oh, oh my God. Jesus. I'm sorry for taking the Lord's name in vain. It looks semi-okay. I'm gonna leave it there. We might even try this. Give it a try. As you can see, the 48 was just the initial value, which will still need to be increased. Since we now shift down by 3, we need to up that by 8 to give it the correct starting position. Oh, looks okay. So what else do we need? We should add some scroll commands here to make the scroll, you know, to give it some more versatility, like scrolling in slowly, or stopping completely, or stopping bouncing and stuff like that. So what else is there to fix here? Okay, so what I want to do is, first of all, I want to change the logo, I think, to, well, modify it anyway. How is the anti-aliasing now that we increased the background color there? Basically, we could get away by just increasing, adding some blue to the anti-aliasing colors. So I'm gonna do that. What was that, logo pal? So we had how the hell should I know which color is mapped to which pixel here? Well, the ones with red components are of course inside the logo, and inside the logo the anti-aliasing works fine. So it's just the ones without red components that we need to look at. So that's a red color. That's a completely gray color. That's a very red color, which is the fill color. Boo, that's probably an anti-aliasing color outside. And the rest of these are... That's a red color. So it helps if you think these things out beforehand. But we don't care right now anyway. We're gonna set the suspected colors to, especially this one, to bright pink or something. To see them, and that's the highlight color, so that shouldn't be changed. We have some in-between colors here. That's a dark gray, sort of. That's a medium gray. That's a half medium gray, so we have 3 grays here. So how about we check that color, if that's used. It is, but it's the dark color, so that shouldn't be changed. So we have the 2 anti-aliasing colors here. That's the light gray, and the other one is the medium gray. So to do that, we just increase the blue component, I think, because the gray was a little bit darker than this blue. I think we could try subtracting 1 from the red green and adding 1 to the blue. Let's try that for size. And immediately it's a little bit better. I'm gonna have a look at the dark gray color there, just to make sure I'm changing the correct pixels. Yeah, so that's not correct. It needs to be... I guess brighter, or what? I'm not sure, but 447 was not the ticket, so 338 might be. It's better, but it needs to be more transparent to that bright color that we had for 4F. So I'm going to keep 44 and go 44A instead. That's almost right. And by the way, this is not hardware, Amiga hardware programming. This is just design stuff. Yeah, that works. And the light gray is not transparent enough, so make that more like 44F. Oops, not that much. We'll see on that. Sort of kinda. still needs to be closer to the blue color, so something like that, but it needs to be brighter. So 77D. Increasing all components by 1. Well, the problem is I think we're using that on the inside as well, so I'm gonna leave this little experiment for now and move on to the moving copper bar, which strangely the cyan colors work better now against the blue background, but green and red, well, I don't know about you, but we have pretty bright colors here, so I'm gonna try to make this monochrome because it might work. And I'm thinking if I want to go red or blue for tint on this. Green was obviously just wrong, just plain wrong, just no. So well, I'm gonna start with this anyway. That's way too gray. I think I want to go red on this. So was the darkest color on that copper bar too bright? Was, I guess, about right. So spread them across this. So what's that? 4, 4, red, green, blue. So 7, 4, 4. TAA. No. D99. And this could be white. We could make it just FEE and D99. Just mirror the colors. You could, if you wanted to, add a shadow and stuff like that. Not gonna do this for the tutorial though. And that looks pretty horrible, if you ask me. So reverse these and make it blue instead. I'm going to keep this at white. White is neutral. It might be that I just exaggerated the saturation on these colors. We'll know in a jiffy. Well, I think that's okay. It's just the darkest color that's a bit too dark. Nice steel blue gray. That works for me. So now we're going to make that go in front of and behind the logo with transparency. And that takes a bit of thinking and coding, so see you in the next tutorial.